Assalamualaikum and good evening to our lecturer for MEB2053, which is Dr. Azrli and Dr. Ajar. My name is HANIZUL bin Abdullah, and as the project director for Group 4, I will lead our group project presentation with the title I'm Suffocating. Assalamualaikum and good evening to our lecturer for MEB2053, which is Dr. Azrli and Dr. Ajar. My name is HANIZUL bin Abdullah, and as the project director for Group 4, I will lead our group project presentation with the title I'm Suffocating. So the objective of our project is to install an air ducting unit inside of a prison cell to meet the outdoor air requirement. So before we installing it, we have done research in France on the outdoor air requirement for a prison cell. So the objective of our project is to install an air ducting unit inside of a prison cell to meet the outdoor air requirement. So before we installing it, we have done research in France on the outdoor air requirement for a prison cell. What is an air ducting unit? Basically, the air duct unit system is critical for distributing air throughout your home or business. For our project cases, air duct will assist in directing heated air from air vents throughout a building. So here are our team member, me myself as the research director, FAUZI as the design engineer, FIRDAUS AZRI as the HAZIQ engineer, and in this project, we will also be assisted by two of our junior engineer, which is NUKMAN and Amir Hafizi. So for the problem statement, we are required to find the number of air duct unit required for a prison cells that can accommodate 8 persons on daily basis and 12 person during festive season, which is 50% increment out from the 8% value just now. So the prison cell will be estimated to be kept for 10 hours a day and 250 days per year. As this is for a research purpose only, here are the schematic of our floor plan. We assume in each cell there are one bed, one toilet, one sink, small window and a grill entrance. Since our prison can accommodate 8 persons, so we will times the area of one cell by 8, which will be equal to total area of 33.6 meters squared. So there are 5 main points that we'll be discussing in this presentation. Firstly, we will be discussing whether the number of air ducting unit required to meet the OAR during normal usage. Then, we will decide whether the installation done previously could still comply with the OAR during the festive season. Then, we will calculate the electrical annual energy cost of air ducting unit for a prison cells by considering the only unit required to be operated during the respective usage. Then, we will compare our finding based on both design scenarios. And lastly, we will propose 2 alternatives to reduce the electrical usage and cost of the air duct system. So for the next part, I'll pass our group presentation to our design engineer, Muhammad HAIKAL FAUZI.
Now for the designation. This is a single air duct to be shared by 8 prison cells. The diameter is 15 centimeters and the air velocity is 8 meters per second. The sketch of this floor plan is the one that includes the air ducts of a single air duct. The cells can contain up to more than 10 people, so it is more than enough. Now for the minimum ventilation rates in breathing zone for prison cell. Using this table, we use from ASHRAE standard 62.1-2010. For the people outdoor air rate, it is 5 CFM per person and 2.5 liter second person. And for area outdoor air rate, it is 0.12 CFM per feet squared and 0.6 liter per second meter squared. Now, moving on to determining the breathing zone outdoor airflow, signified by VBZ, where it is equals to RP times by PZ plus RA times by AZ. RP is the outdoor airflow rate required per person. PZ is the zone population. RA is the outdoor airflow rate required per unit area, and AZ is the zone floor area. And doing these calculations, we came up with our own assumptions. The CPT's minimum standard for personal living space in prison establishments are 6 meters squared of living space for a single occupancy cell plus sanitary facility, 4 meters squared of living space per prisoner in a multiple occupancy cell plus fully partitioned sanitary facility, at least 2 meters between the walls of the cell and at least 2.5 meters between the floor and the ceiling of the cell. We received this information from the European Committee for the Prevention of Torture and Inhuman or Degrading Treatment or Punishments. Using the same source as our previous slide, we came up from our assumptions and calculations that, for one person, assume 6 meters squared of living space plus 4 meters squared of sanitary annex. And hence, For 10 number of prisoners, the room should have at least a total cell area of 42 meters squared. Now, using our assumptions, we can now input the numbers into the formula, where PZ equals to 8 persons. Remember, PZ is the zone population. RP, which is the outdoor airflow rate required per person, is 2.5 liters per second person. RA, which is the outdoor airflow rate required per unit area, is 0.6 liter per second meter squared. And assuming AZ, which is the zone floor area, is 42 meters squared, putting all that into the equation, we will get the VBZ, the breathing zone ventilation rate for prison cell, 45.2 liters per second. And hence, the outdoor airflow required in the breathing zone of the occupiable space or vest spaces in a ventilation zone is 45.2 liters per second. Again, using our source, which is the AZRI standard 62 2001, we use our values for ventilation of prison cell is 20 P per 1000 feet squared, which is the estimated maximum occupancy. And for the outdoor air requirements, it is 20 CFM and 10 liter per second. Moving on to calculating the outdoor air requirement of prison cells for usual days. From the question, the number of prisoners are 8 people on usual days, and using the equation Q equals to AV. From the table of the OAR prison cells is equivalent to 10 liters per second. Hence, the OAR for 8 people equals to 8 persons times 10 liters per second. Hence, the outdoor air requirement for 8 people is 80 liters per second. Calculating volume rate per air ducting. From the question, the number of prisoners are 8 people, the air ducting unit diameter is 15 centimeters, and the velocity of air is 8 meters per second. So putting that into the equation, Q equals to pi divided by 4 times 0.15 power of 2 times by 8 meters squared, where you will get the Q is equivalent to 141.37 liters per second, because in the first step we converted to liter per second by dividing with 1000, where 1 meter cube equals to 1000 liters. Calculating the number of air ducting units required. From what we got earlier, we know that the volume rate per air ducting, which is Q, is equivalent to 141.372 liters per second. The outdoor air requirement for prison cells on usual days is V equals to 80 liters per second. Hence, by using the equation, we can calculate the number of air duct unit required, which is the number N, equals to the V over Q, where N equals to 80 over V, 141.37, we will get 0.5659 units. Rounding off will be 1 unit. Hence, therefore, for 8 people, 1 air ducting units are required. Now, for the designation, this is a single air duct to be shared by 8 prison cells. The diameter is 15 centimeters, and the air velocity is 8 meters per second. The sketch of this floor plan is the one that includes the air ducts of a single air duct. The cells can contain up to more than 10 people, so it is more than enough.
So, I am FIRDAUS, the HAZIQ engineer for this team, and I'm going to present about what happened during festive season. During festive season, the number of prisoners in the jail were to increase to about 50% of the number of prisoners during usual days. So, the main question arises from this matter is our designation earlier can contain the 12 prisoners in one time while also meet the requirement for outdoor air requirement for ventilation? So, let us do some calculation. The first thing to do is we will calculate the minimum ventilation rates in breathing zone for prison cells when there is 12 people in it. We will also get the value that we need for our calculation in a table from the next slide. The table in the slide shows the value of people outdoor air rate, which is RP, and the area outdoor air rate, which is RA, for prison cell. We obtain the table from AZRI standard 62.1 to the edition of 2010. So from the table, we can see that for prison cell, the people outdoor air rate, which is RP, is equal to 2.5 liter per second per person. And for the area outdoor air rate, which is RA, we can see from the table that the value is 0.6 liter per second meter squared. So by using the values that we have gotten from our previous table, which is table 6.1, minimum ventilation rates in breathing zone for prison cell, we will use the same equation that we have used in our first calculation, which is VBZ equal to RP times PZ plus RA times AZ, where VBZ is the outdoor airflow required in the breathing zone of the occupiable space or spaces in a ventilation zone, whereas AZ is zone flow area, PZ is zone population, RP is the outdoor airflow rate required per person, and RA is outdoor airflow rate required per unit area. So the value we have got is that PZ is equal to 12%, which was stated in the question, and the value of RP is 2.5 liter per second per person, and the value of RA is 0.6 liter per second meter squared. So in this calculation, we will assume AZ is equal to 42 meter squared. So by using the equation below, we have calculated and we have got the value of VBZ is equal to 55.2 liter per second. Hence, the outdoor airflow required in the breathing zone of the occupiable space or spaces in a ventilation zone is 55.2 liter per second. Moving on, now we will calculate the value of OAR values for ventilation of prison cell in a prison when there is 12 people in it. By looking at the table below, the outdoor air requirement for one person in a prison cell is equal to 10 liter per second. After we have got the OAR values of OAR for one person, now we will calculate the values of outdoor air requirement during festive days when there is 12 people in it. So from the table earlier, it stated that for one person, the value of outdoor air requirement is 10 liter per second. So by multiplying the value with 12%, we will get the values of outdoor air requirement for 12 prisoners, which is 120 liter per second. Now we will calculate the volume rate per air ducting. The equation that we will be using is Q equal to AV. From all the information that we have get earlier, we know that the number of prisoners during festive days is equal to 12 people, while the diameter of an air ducting unit and velocity of air is equal to 15 cm and 8 meter per second respectively. So from the equation QAV, we managed to calculate the values of Q and we get 0.141372 meter cube per second. By dividing the answer with 1000, we get the same values of Q with a different unit, which is 141.372 liter per second. So now we can get the number of air ducting units that we required to install in our prison cell. From what we get earlier, we know that the volume rate per air ducting is equal to 141.372 liter per second, and the value of OAR for prison cells in festive days is equal to 120 liter per second. Hence, by using the equation below, we can calculate the number of air ducting unit required, and the equation is N equal to V over Q, which is N is the number of air ducting unit required. So, after we have calculated, we get the number of air ducting unit that we require to put in our prison cell is equal to 1 unit. Therefore, for 12 people, 1 air ducting units are required to be installed inside the prison. So now, you must be asking, is the installation that we have done earlier could still comply with the OAR during the festive season? So, my answer is yes. However, the authorities needs to add one more air ducting system if the number of prisoners become more than 15 people. And we will show you in the next slide on how we get those exact number of 15 people. So now, I will show you how we get the number of maximum possible people for one unit of air duct. To calculate the maximum number of possible people, volume rate per air ducting Q must be equal to the OAR for prison cells, which is V. Hence, we can compute that V is equal to Q and is equal to 141.37 liter per second for one person. Therefore, based on the equation that we have used before, which is OAR for a specific number of people is equal to OAR for one person times by number of people, we can get the maximum number of possible people for 1 unit of air duct. So, we have calculated and we have get the number of people that is required for 1 unit of air duct is 14.137 people. And the answer is approximately is 14 people. Therefore, we can conclude that the number of people or prisoners for one air duct are 14 people. So, if there are 15 or more prisoners to be transferred into the prison cells, the authorities need to add one more air ducting system into the prison.
Hello, my name is Amir Hafizi, and I will show you the calculation on electricity annual energy cost and also comparing the findings in a table form to conclude it appropriately. So, for the electricity annual energy cost, we are using 1 air duct units for both in festive days and also during normal days. So, as an assumption, there are 30 days festive days as a part of 250 days in a year. So, during normal days, which is 220 days, they will be using 0.05 kilowatt every each hour, and also during a day they will be using 10 hours, and for 220 days the electricity usage will be 110 kilowatt hour. Since the number of air ducts units is 1, so it will multiply by 1, so the electricity usage is 110 kilowatt hour. And during festive days there are 30 days, and for each day there are 10 hours, and for the electricity usage is 15 kilowatt hour. And since number of prisoners are 12 persons, the air ducts is still 1 unit, and so the electricity usage is still 15 kilowatt hour. Hence, with the total electricity usage will be 125 kilowatt hour. And for the cost in the France for the electricity prices, it will be 0.126 euro for each kilowatt hour. So for the annual energy cost, it will be cost you 15.75 euro. Now I will compare the findings in our project based on the calculation made by us. Firstly, as mentioned before, we assume that in a year there will be 30 festive days and 220 normal days, which total of 250 days altogether. As given on the normal days, the occupancy is 8%, while in festive days, the occupancy increases by 50%, which is 12%. And based on this number of occupancy and calculation that were made, the result shows that there is no need for additional air ducting unit during festive days. Therefore, it is only required to install only 1 air ducting unit in the prison. However, as mentioned before, if the number of occupancy increases to more or equal than 15%, it is compulsory to install an additional air ducting. Lastly, the annual energy usage and costs are calculated based on the amount of air ducting used. As for 220 normal days, the energy usage is total up to 110 kilowatt hour, while during 30 festive days, it is total up to 15 kilowatt hour. Summing up both of them for 250 days, their energy usage is 125 kilowatt per year. And after that, according to the France electricity rate of 0.126 euro per kilowatt hour, annual energy cost will be 15.75 euro.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Haziq NUKMAN, ID 201560, and for my part, I'll be presenting about the alternative, reflection, and also the infographic of this presentation. Okay, by the end of our study, we have came to conclusion for the alternative to reduce the electrical cost and also the usage by giving 2 proposals. The first proposal or alternative would be by servicing the air conditioning system. We should have a regular service by cleaning the filter every few months. By this, we can greatly reduce the energy consumption between 5 to 15% in total. For the second alternative, we propose to increase the number of windows in-house in order to reduce the electrical cost and also the usage. When in heating season, we can greatly reduce the heat loss through the window by approximately of 40% or more, instead using the ducting system. This will eventually equate about 10% of heating energy saving. On the other hand, when in cooling season, by increasing the number of windows, we can reduce the unwanted solar heat through the window by approximately of 60%, and subsequently reducing the total energy solar gain to 20% in total. Next, as a reflection of our study in regards of the outdoor air requirement complaint, at the end of our research, we are able to identify the number of air ducting units that are required in our venue to meet the OAR, where we conclude that during normal usage, we are needed around 3 units, and during festive season, we needed around 5 units. And a reflection in regards of the annual energy cost, we are able to make the calculation related to the electricity annual energy cost, which costs around 75 ringgit Malaysia for 375 kilowatt per hour. For electricity usage for 3 units of that air ducting units. And also a reflection of the alternative, we also able to propose alternative in reducing the consumption and the cost of electricity by giving two proposals, which are by adding windows at the venue and also giving a regular service of the units. Here, as a conclusion, I will be explaining a bit about our infographic that we have produced as an outcome of our research studies. For our infographic, we team 4 has come to conclusion on proposing the alternative to reduce the electrical usage and also the cost of air ducting system. We have summarized the alternative and put it into the infographic to ease other people to understand. We have explained the two alternatives to handle, which first by servicing the air conditioner, and next one is by increasing the number of windows in-house. We also explain how the alternative can help reduce the electrical usage and cost during heating season and also cooling season. Therefore, that concluded all of our presentation. Thank you for tuning in, and please contact us if there are any inquiries. Thank you. Therefore, that concluded all of our presentation. Thank you for tuning in, and please contact us if there are any inquiries. Thank you. Therefore, that concluded all of our presentation. Thank you for tuning in, and please contact us if there are any inquiries. Thank you. Therefore, that concluded all of our presentation. Thank you for tuning in.